So looking at target 2.1, what we're going to be working on today is I can simplify radicals and rationalize the denominator of a fraction. So the first thing we're going to look at is what is a radical. A radical is the inverse or opposite operation of an exponent. So just like adding and subtracting are opposites, right? Multiplication and division are opposites. Exponents and radicals are opposites. So you can look here, right? Since 2 squared equals 4, the square root of 4 equals 2. And since 2 to the third equals 8, the cube root of 8 equals 2. Okay, so they are undoing it, right? The cube makes it go to 8. The cube root takes it back to 2. The squared makes it go to 4. The square root makes it go back to 2. Okay, so again, radicals are like undoing your exponent. In this class and in this section specifically, we are going to just be looking at squares. Okay? So we're not going to worry about cube roots, or there's all sorts of roots, 4th roots, 5th roots, whatever. We're really going to be focusing on square roots. So in order to know what our square roots are, we need to know what our perfect squares are. Okay, and perfect squares are the number you get when you square something. So 1 squared, which is the same as 1 times 1, is 1. 2 squared, which is the same as 2 times 2, is 4. 3 squared, which is the same as 3 times 3, is 9. 4 squared, or 4 times 4, 5 squared, or 5 times 5. All right, 6 squared is 6 times 6, which is 36. 7 squared is 7 times 7, which is 49. 8 squared, or 8 times 8, is 64. 9 squared, 9 times 9, is 81. 10 squared, which is 10 times 10, is 100. Those we probably kind of know, or we could easily figure out. It's the bigger ones, right, as we get past 10 are harder. But 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. And 15 squared is 225. So these are our perfect squares. Okay. And I would say for the most part, you're going to want to have these memorized to an extent, right? It doesn't have to be perfectly memorized, but kind of be able to recognize them and use them, right? And really the most important ones are past 1. We don't care about 1 as much. We'll see when we're simplifying why we don't so much care about 1. Well, I can say no. It doesn't really change anything, right? If I take out a 1, the number doesn't change. When I square root it, it doesn't change. So since it doesn't change our number, and it's a part of every number, we don't care about it. All right, so now we're going to take square roots of numbers, and these perfect squares are very important in doing that. Okay? So let's look at example 1 here. I want to find the square root of 81. Well, pretty simple, because we know that 81, if we look right here, 81 is 9 squared. So I can write this as the square root of 9 squared. And then our square root and our squared cancel out, and I'm left with 9. So we're all looking on this list of highlighted numbers, right, to find those perfect squares, because we can take the square root of perfect squares. Looking at example 2, I want to find the largest perfect square. I want to find the square root of 20, but it goes from 16 to 25. 20 is not on our list of perfect squares. So what we have to do is find the largest perfect square . Find the largest perfect square . That divides, that's not how you spell into. No, divides into 20. So what I'm going to do is I'm going to take the number 20 and I'm going to start dividing. I'm just going to use the little calculator so we can see what we're doing. Well, the smallest number that comes, right, or the largest number that's still smaller than 20 is 16. So 20 divided by 16. That does not divide evenly. This is not an integer, so 16 doesn't go into it. I'm going to do 20 divided by 9. That is not an integer. Oh, 20 divided by 4 gives me 5. I'm going to write that down here. Divided by 4. Okay, 20 divided by 4 equals 5. So I found a perfect square that divides into 20. So I'm going to split this number into, I want to use my perfect square, 4, and the number I got. Okay, so it's 4 times 5. Again, since 20 divided by 4 is 5, then 4 times 5 is the same as 20. Now what I'm going to do is I'm going to split this up. So really the same as the square root of 4. Okay, so I can split my two radicals up. And then I chose 4 because it's a perfect square, and 4 is equal to 2 squared, right? So this is really in this one, since I have it as something squared, the squared and the square root cancel out. So I'm left with 2. 5 is not a perfect square. It stays exactly how it is. Okay, let's look at part C. We have square root of 96. Again, I'll look in my list of numbers. 96 is not in my list of numbers. It'd be between 81 and 100, and it's not there. So I'm going to start dividing. I'm going to start with 81 because that's like the biggest number that's still smaller than it. I do not get a nice integer, so that's not it. 96 divided by the next one down is 64. Nope, not an integer. 96 divided by 49. Nope. Divided by 36. Nope. Divided by 25. No. Divided by 16. Oh, there we go, right? 6 is a nice, perfect integer. So I'm going to use 96 divided by 16 equals 6. So again, I'm just kind of dividing all of my numbers. Write that on the side. 96. 96 divided by 16 equals 6. So I'm going to write this as the square root of 16 times 6. I'm going to split them up. Well, again, we chose 16 as a number we can divide by because 16 is really 4 squared. So our squared and our square root cancel, and we're left with 4 square root 6. Okay, let's look at part D. We're doing the square root of 18. So again, I'm going to look at my perfect squares. And again, 18 is not in this list of highlighted numbers. Okay, it would be right here between 16 and 25. So I am going to have to divide. So I'll do 18 divided by 16. Nope. 18 divided by 9. There we go, right? 18 divided by 9 is 2. Okay? So this whole process of finding your perfect square is a little bit guess and check, right? And as we keep doing things where we have to simplify radicals, you'll start seeing them easier, right? You might not have to start dividing by every number. You'll know like, oh, it's going to be one of these. But you can divide by everything till you find the one that works. So as we saw here, 18 divided by 9 So this is going to be the square root of 9 times 2. I split that up and I get the square root of 9 times the square root of 2. Again, we chose 9 as a number we can divide by because 9 is actually 3 squared, right? It's a perfect square. Our square root and our squared cancel. We're left with 3 square root 2. Okay. The next thing we're going to look at is rationalizing the denominator. So, rationalizing the denominator. When dealing with fractions, a final answer cannot contain a radical in the denominator. So you cannot have a square root in your denominator. So, questions you're asking yourself. 1, does the fraction even have a radical in the denominator? If it does, right, then you have to do something. If not, you don't have to do anything. Okay? So number 2, only if yes do you continue, right? So if it does have a radical in the denominator, you want to simplify it if it can be simplified. Not every radical can be simplified, and we'll see an example of that. Okay, but you do want to simplify it. And then 3, multiply both the numerator and denominator by that radical. We'll see why that helps us out. So, let's look at what we're doing. Example 2, 3/8. Well, if we look at this first example, right, 8, this is not a radical. So there is no radical in the denominator. So we're done. I don't have to do a single thing to rationalize this denominator. It is a rational number. This is just an example of don't try to force things to happen that don't need to happen. 3/8 is just a regular old fraction with no radicals. Okay, let's look at our next one. 7/√5. Well, if I look at that number 5, right, we can try to simplify it. But if I go back up here, right, 5 is between 4 and 9. So when I divide, 5 divided by 4 doesn't work. The only other number left is 1. And our rule is, and I'll write it here, 1 is the largest perfect square. So it's already simplified. Okay, so if 1 is the largest and therefore only perfect square that divides your number, you don't have to do anything. It's already simplified. There's nothing more you can do. Okay? So really, we did step 2, right? Technically, it's already simplified, so I don't have to do anything more. So we're going to look at step 3. We're going to multiply both the numerator and denominator by the radical. So we have 7 square root 5. So what that means is I'm going to take this 7 square root 5, or 7 divided by square root 5, and I'm going to multiply both my numerator and my denominator by square root 5. So then in our numerator, we have 7 times square root 5. 1 doesn't have a radical, 1 does. So all I can do is leave that as 7 square root 5. And let's look what happens to the denominator. Well, square root 5 times square root 5 is the same as square root 5 squared. Right? That's what squared means. You're multiplying something twice. So square root 5 times square root 5 is the same as square root 5 squared. And now we have a square root and a squared that cancel each other out. So I'm left with 7 square root 5. And in my denominator, I'm just left with 5. Next question, we do have a part C. 8 over 3 square root 2. Step 1, is there a radical? Yes, it's right there, right? That's square root 2. So we do have to rationalize. 2, is our radical simplified? The only perfect square that's going to divide 2 is 1, right? 2 is such a small number. So yes, square root of 2 is already as simplified as we can make it. We can't do anything else. So step 3, I'm going to multiply both the numerator and the denominator by that square root 2. So we get times square root 2 and times square root 2. So then I have 8 square root 2 in my numerator. And then in my denominator, I have 3. So we just have to bring that 3 down. And then I have square root 2 times square root 2, which is square root 2 squared. Okay. So again, the biggest thing here is we're not multiplying by the whole denominator. We're just multiplying by the radical, right? So there is 3 square root 2, but we're just multiplying by that square root 2 part. Now again, our square cancels that square root out. So I have 8 square root 2 over 3, and then 2. And these are technically being multiplied together. You don't just write 3, 2. That would look like 32. This is 3 times this 2 that comes out of there. Well, I know what 3 times 2 is. And then the last thing we want to look at is if our fraction can be simplified. And you need to leave it as a fraction. Okay, this is where Desmos comes in very handy. So I'm going to go to my graphing calculator on Desmos. Or not my graphing calculator, my scientific calculator in Desmos. Do 8 divided by 6. Again, you cannot put it as a decimal. You must have it as a fraction. So you have to click this button, and you get 4 over 3. So I'm going to write this as 4 square root 2 Okay, looking at D, last one. Again, we asked ourselves 3 questions. Is there a radical? Yes, I see it right there. Number 2, can it be simplified? Well, let's start dividing, right? 27 divided by probably 25 is our next. Divided by 16. Ooh, 27 divided by 9 gives me 3. So I was just going through that list. I just didn't scroll up to it. So I do have to start by simplifying this radical. So I get 18 over the square root of 9 times 3. Which will give me 18 over square root 9 times square root 3. As you start getting better, right, really this is 18 over the square root of 3 squared times square root 3. Right? Again, we chose 9 because it's a perfect square. Which is 18 over 3 square root 3. So that was just the simplifying part. Now, I still have to do step 3, where I have to multiply by my square root, right? By that radical. So I'm going to multiply by square root 3, which gives me 18 square root 3 over 3, and then square root 3 times square root 3 is square root 3 squared. Which is 18 square root 3 over 3 times, well, square root 3 squared, the square root and the squared cancel. Which gives me 18 square root, well, 3 times 3 is 9. And again, we always want to check if this divides. And it does. 18 divided by 9 is 2. Questions on this problem? It's a little bit longer, but it's just really combining. It's like 2 problems in one. It's a simplifying problem and then a rationalizing problem.